Good morning. This is your Stat Sensei, Mr. Spensei, and this is Death Packet Answers, questions 51 through 60. So car insurance policies for teenagers have higher premiums than for adult drivers because teenagers are considered to be a high-risk population. Suppose the average cost of teenagers age 16 to 19 is 3,025. So we know that we have a mean of 3,025, and we also have a standard deviation of 430. Is there sufficient information to answer either or both of the questions? What is the probability that a randomly chosen teenager pays over 3,000? I should not have an extra zero, $3,000 a year for auto insurance. Okay, here it says a randomly chosen, so we're looking for one. All right, well, we have a problem. In order to do this, it has to be normal, right? It has to be normally distributed. But in this case, we know it's not. All right, we know it's not because some teenagers are going to be very, very expensive and some are not. So because it's skewed to the right with very high on the one end, this is not normal, and they didn't tell us it was normal. If they told us it was normal, it's okay, but they didn't tell us it's normal. We can't do problem one, so not possible because they didn't tell us it was normal. The next one, what's the probability that the average amount paid in a simple random sample of 50? Well, here we're talking about average. We're talking about the X bar, and we have a simple random sample of 50. So in this case, we could do this one, all right, but we cannot do the other one, all right? So the question is on 51 is there, uh, so in this case, there is sufficient evidence because we can sit there and go, you know what? With a sample of size 50, the sample size 50, the mean is going to be 3,025. And we're going to have, because the mean is the mean is the mean, and we're going to have a standard deviation of 430 divided by square root of 50. So they're telling us that the mean right here, so the mean is 3,025, and the standard deviation is 430 divided by square root of 50. So we're good with that. And that's what it says in E, but that wasn't what the question is. It says, is there sufficient to answer either or both? Well, there's not enough information to answer one, but there is enough answer to answer two. Sufficient to answer question two, but not question one. So our answer choice is C. All right. Now 52 is a skip because the answer choices are messed up. Hopefully I'll have those fixed for next year. But I'm going to go ahead and work through the problem. Two 95% confidence intervals will be constructed to estimate the difference in means of two populations R and J. One confidence interval I 400 will be using samples of size 400. So we'll have an interval with 400. All right, so N is 400. And we'll have a second one that has a interval of size 100. So we have 100 and 400 and 100 are my sample sizes. When all things remain the same, in other words, they have the same standard deviations, which of the following describes the relationships between the two confidence intervals? Okay, first off, we know that this will be narrower because it has a larger sample size, and this will be wider because the margin of error goes down as N goes up. As the sample size goes up, the margin of error goes down. Now, if we look at our confidence intervals, they're essentially taking the square root of the sample size. So if I take 100 over 400, well, first off, this crosses out, and I end up having the square root of 1/4, which is basically the square root of 1 over the square root of 4, which is square root of 1 is 1, and 1/4 is the square root of 4 is 2. And you could have done that on a calculator just as easily. You could have gone 100 divided by 400 and raise that to the half power. And sure enough, we get 0.5. So the ratio is the width of 400 will be half the width of 100. So this should have been D, which should have said 1/2. All right. So D would have been 1/2. It's 1/2. The interval 100 is twice the width of interval 400 because this is wider. It's twice as wide. Okay. That answers question number 52. Number 53. 299% confidence intervals will be constructed to estimate the difference in means of two populations R and W. One interval 9 will be constructed with samples of size 9. So we'll have interval 1 equals 9. And the other confidence interval will be interval 2 will be 81. All right. When all things remain the same, which of the following describes the relationships between the two confidence intervals? Well, this one will be wider and this one will be narrower. And I know this once again because as the sample size goes up, the margin of error goes down. So this one's going to be wider. This is going to be narrow because this one has a larger sample size. All right. So I-81. Well, let's go ahead. Will be what the size? Well, let's go ahead and set up a ratio of it. So we basically have 9/81. And remember, our denominator was always taking the square root of that. So we need to do that. And I can reduce this, but I'm just going to speed ahead real quickly and go 9 divided by 81. And I'm going to hit a math enter, so it's a fraction. So 1/9. So this ends up being the square root of 1/9. And you could have reduced that yourself. Well, the square root of 1/9, let's raise that to the half power. And we get 1/3. I'm going to go math enter. So our fraction is 1/3. And that's the same as saying the square root of 1 over the square root of 9, which is 1/3. So the width of 81 will be 1/3 the width of the one with a 9. All right. The width of 9 will be 3 times the width of 81. Now, one thing you have to be careful of is this one, they're trying to mess you up with the 1/9. They wanted you to forget to take the square root. So don't forget to take the square root. 54. A manufacturer of piston rings for automobile engines frequently tests the width of the rings for quality control. Last week, a random sample of 15 rings were measured, and the mean and standard deviation of the sample were used to construct a 95% confidence interval for the population mean width of the rings. When all things remain the same, which of the following conditions would have resulted in a wider than the one constructed? Okay, so if n goes up, or if excuse me, how do I say this? Um, n goes down, the margin of error goes up. That means it's wider. All right. As the confidence level goes up, the margin of error goes up, which means it's wider. So we're looking for sample size going down and we're looking for confidence level going up. Well, this went to a larger sample size. That's not, we want to see a smaller one because we were looking for a wider interval. Same size interval or sample size, but our confidence level went up. Confidence level goes up, margin of error goes up. Sample size goes down, then the margin of error goes up. So in this case, our answer choice is going to be 2 and 3. So our answer choice for 54 will be E. A government statistician claims that the mean income of families living in subsidized housing is $9,250 with a standard deviation of 2575. A reporter plans to test this claim through interviews with a sample of 50. If she finds a mean more than 500 different, that's a key word, from the claim 9,250, she'll dispute the statistician's claim. What's the probability they will mistakenly reject a true claim? All right. So we need to sit there and we need to go, well, what's the probability they will reject it? The easiest thing to do, since they gave us a population standard deviation and the population mean, we go ahead and run a stat test z-test. Stat test z-test. And basically what we're looking for is either a value of this is where the population mean is supposedly at 9,250. If she gets 9,750 or more, or if she gets 8,750 or less. Now you can run this one of a couple ways. I'm going to run this as a not equal to, and it doesn't matter whether you choose 9,750 or 8,750 as your X bar, it won't matter. I'm going to use stats, mean of 9,250, standard deviation 2575, X bar. I'm going to use the 9,000. Actually, I'll use the 8,750. And I'm going to have a sample size 50. I'm going to use not equal. Oops. Went through the buttons too fast. All right. So I get a p-value of 0.1697. And my closest answer is this. What if I would have used 9,750? I get the same thing. Now, some of you are going, well, what if I would have just said, hey, could I have done a greater than one of them or a less than the other one and checked and doubled it? Well, yes, you could have. You could have gone stat test, Z test, and we'll use the 9,750 since I already have it in there. And I'll press greater than and calculate. I'd have to double that p-value. If I double that p-value, I'm going to get what I originally had, which is about 17%. So the best answer for 55 is C. Number 56. Research has shown that tornado wind speeds are normally distributed, all right, with a mean of 112. Consider a random sample of 10 tornadoes each, all right? So in this case, the variable blank, what can we say about it? Well, when we look at it, it's like, you know what? The mean is 112. The standard deviation is unknown. We have the square root of 10. And so with 56, it's a t distribution. And the reason it's a t distribution is because we're using the standard deviation of the sample, and that has the degrees of freedom of n minus 1 or 10 minus 1, which is 9. So in this case, it's a t distribution because we're using S, the standard deviation of the sample. Number 57. A random sample of 10 employees of a company was selected to estimate the mean one-way commute time for all employees at the company. The mean and standard deviation of the sample were 38 and 6 minutes respectively. So we ended up with an X bar of 38 and we ended up with an S of 6. Assuming all conditions are met, Which of the following is the margin of error in minutes for a 95% confidence interval for the population mean one-way commute time? Well, margin of error is X bar plus or minus T star S divided by square root of N. So this right here is my margin of error. And this part right here, well, that right there is the margin of error. And that's really all we care about. So let's go ahead and focus on that. Our sample size in this case was 10. So we're going to have 6 over the square root of 10. Well, unfortunately, they all have that. So the tricky part is going to be getting the right T star. Well, to do T star, we're going to have to do inverse T. And it's going to ask for our area. And our area is going to be 1 minus the 0.95 divided by 2. And then it's going to ask for our degrees of freedom, which in this case will be 10 minus 1. So let's do that. Second vars, inverse T, parenthesis, 1 minus 0.95, close parenthesis, divide by 2. Degrees of freedom is 10 minus 1. And we end up getting 2.26. Well, the one that's closest to 2.262 is letter E. All right. Number 58. Researchers at medical center studied the amount of caffeine in milligrams contained in a 16-ounce cup of coffee made at one machine at the center's cafeteria. They selected a random sample of 40. 16 ounces of coffee made different times of the day, a 1 month period. The mean and standard deviation were 159.88 and a mean of 36.72 milligrams. All right. So the mean was 159.88, or excuse me, the X bar. And the sample standard deviation was 36.72. And we previously said the sample size was 40. All right. A graph of the sample data revealed a right skew with one outlier. The researchers will construct a confidence interval to estimate the amount of coffee for all 16-ounce cups made with the machines. Which of the conditions is not needed for the inferences? All right. So, and right here, they said right skew with one outlier. But we have a sample size of 40. The samples were selected at random. You always have to have that. We have to have that. So that's something we have to have. The observations were independent of each other. Yeah, we really have to have that every single time too. The sample of 40 is less than 10% of the population. Yes, we have to have that. These two very much related. All right. But also, if they're random, they tend to be independent. And they also remain independent if they're less. So these three kind of go together. The graph of the sample data is symmetric with no outliers. We do not have to have that. And we don't have to have it because n equals 40, which is greater than or equal to 30. And as long as we're 30 or more, we don't have to have this. All right. So the answer choice to 58 is D. 59. An agency that hires out clerical workers claims its workers can type an average of at least 60 words per minute. So this is their mean. This is the population. This is their claim. To test the claim, a random sample of 50 workers, so n equals 50, from the agency were given a typing test and the average speed was 58.8. So the X bar is 58.8. A one sample t-test was conducted to investigate whether there's evidence that the mean typing speed from the agency is less than 60. So they're saying, hey, you know what? This is the claim. The mean is 60. The alternative, the mean is less than 60. Which of the following is a correct interpretation of p-value? All right. Well, p-value is the probability of getting a test statistic or a sample statistic this extreme or more given that the null is true. All right. So here, if the mean typing speed of the workers from the agency is 60, so if this is true, The probability of selecting a sample of 50 workers with a mean of 58.8 or less is 0.267. All right. And it's always based, and the difference between these two is this was based on the alternative. We don't say if the alternative is true, it's if the null is true. So if the null is true, there is a 0.267 chance that we'd get a test statistic like this or a sample statistic like this. All right. That's the definition p-value. 60. The local ranger station tracked and tagged 2,844 adult female black bears in a national park at a random sample of 9 adult bears. From those tags had an average body weight of 203 pounds with a standard deviation of 25. Which of the following is a point estimate for the population mean of all? All right. So when we do a confidence interval, X bar plus or minus T star S divided by the square root of N, this is the margin of error. And this right here is my point estimate. And by the way, if you had to choose a single point that's the single point that's the best is the average. So, body weight of 203 pounds. Well, guess what? That's the average. That's my answer. All right. Well, appreciate you watching and hope to see you on the next one. Thank you.